Hi everyone, welcome to Algebra 2, Chapter 6, Lesson 4, Factoring Polynomials. In this video, we're going to talk about a few methods that we're going to use to factor. So let's take a look at the factor theorem first to determine what is a factor of a polynomial. The factor theorem says if a polynomial is divided by a binomial and the remainder is 0, then the binomial is a factor. So basically, if you want to determine if a binomial is a factor of a polynomial, just divide and check your remainder. So I have an example here. I divided my polynomial by this binomial using synthetic division. And when I did that, I got a remainder of 0. So in this case, x minus 2 is a factor. And if you wanted to know the other factor, this would be the result down here. This is x minus 2 again. So x minus 2 times x minus 2 will get you this polynomial here. So let's start off with just examples where you have to divide to determine if it's a factor. And then the answer is just yes or no. Is it a factor? In example 1, it asks you to determine whether the given binomial is a factor of the polynomial. So it gives you these two examples. Do some division, check your remainders, and say yes or no. Is it a factor? And then hit play to check your answer. For part A, I have my synthetic division here, and notice my remainder is positive 12. It is not 0. So x minus 3 is not a factor of x squared plus 2x minus 3. In part B, I did my synthetic division. Don't forget to add in the 0 for the x squared term. And I did get 0 as my remainder. So x plus 4 is a factor of 2x to the 4th plus 8x cubed plus 2x plus 8. So let's move on to a different type of factoring. Now that we know how to tell if something's a 0, let's look at factoring methods. And we're going to start off with factor by grouping. So we're going to take a look at factor by grouping. You need to have 4 terms in your polynomial in order for this to work. And what we're going to do is we're going to take our polynomial and group the terms into pairs. So notice in my example over here, I took the first 2 terms and I put parentheses around them. Then I took the next 2 terms and I put parentheses around them. I like to leave a plus sign here because if you don't, it's going to look like multiplication. That's not what's happening. This was all adding. And if this had been a minus 6x, I would put the negative in here and still put the plus out there, just because I don't want it to look like this whole thing was subtracted, because it wasn't. And so that helps me not make errors with my signs. Step 2 is you're going to factor a GCF out of each pair. So I'm looking at this first pair and I find the GCF is going to be x squared. That's what they share. So I wrote the x squared on the outside. And then I wrote what was left over on the inside. So I had 2x plus 3. Now for the next pair, I need to factor out the GCF, which is 3. And I factored out a 3. It was positive 3, so I left the plus sign. And then I had 2x plus 3. Now this next step is actually factoring. What I like to do is I like to take the part that matches the 2x plus 3 and the 2x plus 3, and I write it here once. Then I take the other parts, x squared and plus 3, and I write it over here in their own parentheses. It is actually factoring. You're factoring the GCF of both of these terms. The first term is this x squared times 2x plus 3. And the second term is this 3 times 2x plus 3. And they share the 2x plus 3, so you're factoring that out as a GCF. But just take the one that repeats, write it once, take the GCFs and write them in their own parentheses. The final step is to check for further factoring. Sometimes this x squared plus 3 can be factored further. In this case, it can't. The times that it would be factored further would be when it's a difference of 2 squares. So if this was like x squared minus 16 or x squared minus 9, then that could be factored further. You would do that factoring and just keep this 2x plus 3 on the other side. Okay, so let's try some examples of this. So in this example, you just have to factor by grouping for both of these. And I'll give you a hint, both of these can do that factor further step. So try to factor this as far as possible and then hit play to make sure your answers are correct. What I did is in the first example, I grouped my x cubed and my 3x squared plus, now notice this was negative 4x plus minus 12. I kept this minus sign right here and I did a plus here. Then I factored out the GCF. For this first pair, it was x squared, and I was left with x plus 3. For the next pair, it was negative 4, and I was left with x plus 3. Notice the sign there was negative because I knew this was a positive x, so I wanted to make sure that this would be a positive x because they have to match. So then I wrote my x plus 3 here, and x squared minus 4 I wrote here. And the order of these binomials does not matter because it's multiplication. But this x squared minus 4 can factor further. So I have x minus 2 times x plus 2 because it's a difference of two squares. Now in part B, I did the same thing. I grouped the first two terms and I grouped the next two terms. Again, watching the sign on that 9x. Then I factored out a GCF of x squared. Here the GCF was negative 9. X squared minus 9 and x minus 2 were here. And the x squared minus 9 could factor further to x plus 3 and x minus 3. Okay, next we're going to look at another type of factoring. It's another very special pattern, similar to a difference of two squares, but we're looking at cubes this time. If you notice that two cubed terms are added or subtracted, you can factor it. What you do is you take the cube root of the first term, the cube root of the next term, you write a plus sign in between, and then you take those cube roots. For the first term, you square it, you multiply the cube roots together, a times b, and then you square the second cube root. And notice, if this was plus, you're going to have a minus sign next, and then a plus sign. The only thing that's different if this was a cubed minus b cubed is where that minus sign goes. So this first binomial always has a sign that matches the original sign. And you're only ever allowed to have one minus sign. So if this is minus, then this has to be plus and plus. So this is my example. I have x cubed minus 27. The cube root of x cubed is x, and the cube root of 27 is 3. So the factored form is x minus 3, because that was the two cube roots subtracted with the same sign that was here. And then you square the x, you do 3 times x, and you square the 3. And remember, there's only ever one minus sign, so if I use it here, I can't have one here or there. So we're going to take a look at some factoring ones next. You need to factor each expression completely, and yes, they will both use the sum or difference of two cubes, but in part A, you have to factor out a GCF first before you can see the cubed terms that are in there. So try it, and then hit play to see if you're right. In part A, I factored out the GCF, which was 5x, and I was left with x cubed plus 8. I noticed that these were both perfect cubes. The cube root of x cubed is x, and the cube root of 8 is 2. So I wrote x plus 2 here, making sure to carry down the sign. And then I squared the x. I did 2 times x. And then I squared the 2. Now, I didn't have a minus sign here, so that's why this sign is minus. And the last sign is always a plus. In the other example, I noticed that these were also perfect cubes. The cube root of 8y cubed is 2y, and the cube root of 27 is 3. So I wrote those down, and I copied the minus sign. Then I did 2y squared, which gets you 4y squared. I did 2y times 3, which is 6y, and then I did 3 squared. Now I already used the minus sign, so I have to do plus and then plus. And those are factored. We have one last example to look at. In example 4, it says the population of an endangered species of birds in the years since 1990 can be modeled by the function p of x equals negative x cubed plus 32x squared minus 224x plus 768. Identify the year that the bird will become extinct if the model is accurate and no protective measures are taken. Use the graph to factor p of x. So we're going to pretend that we're living way back in 1990. And we're going to take a look at this graph. If the graph shows the population of the bird, take a look at this red line. When the population is 0, that's when it becomes extinct. So population is 0 right here. So that's after 24 years. Now, in the very, very first example we did, we talked about how to start factoring a polynomial by using those zeros. So try using synthetic division with that 24 that we just got to start the factoring on this. And then hit play to see the rest of what we're going to do. So what I did is I took the 24, and that's what I'm factoring out. I wrote my coefficients here, and I did synthetic division. Please notice that the remainder is 0, which is good because I knew that 24 was a 0 of this, which means it is also a factor. So that's where this x minus 24 came from. All I did is I said, well, if this was a binomial, it would have been x minus 24. You change the sign on the 0 to get the binomial. Now, the rest of the factored form, I just took these numbers and I wrote the result of my division here. And the only other thing I can do to factor this any further is to factor out this negative sign from the x squared. But that's kind of optional. It's okay to leave it there. But oftentimes we like our leading term to be positive. So that's why we often do factor it out. Now, 32 and negative 8, you cannot factor this any further. The multiples of 32, the factors of 32 are just 4 and 8. You get 16 and 2, 32 and 1. There isn't much there that you can actually factor, and none of it will add to negative 8 and get you positive 32 there. So that's as factors as it goes. The last thing I wanted to do was take my 24 and tell what year actually the birds became extinct, and that was in 2014. All I did was I took the starting year plus 24. Okay, so that's it for this lesson. Please let me know if you have questions, and have a great afternoon.